Mercury races around the Sun faster than any other planet, completing a full orbit in just 88 days. But did you know that despite this speed, a single day on Mercury, the time it takes for the Sun to return to the same spot in the sky, lasts twice as long as its year? That's right, one day on Mercury equals 176 Earth days. How many people do you think are aware of this mind-bending fact about our solar system's fastest planet? What is greatest elongation east? Mercury is often called the elusive planet because it's so tricky to spot in the sky, hidden close to the blinding glare of the Sun. But there's a special moment when Mercury steps out from the Sun's shadow and becomes visible in the evening sky. This moment is called greatest elongation east. At this point, Mercury reaches its maximum angular distance east of the Sun, meaning it appears farthest away from the Sun's glare as seen from Earth. This event is a golden opportunity for sky watchers because it's when Mercury shines brightest and is easiest to spot just after sunset. Since Mercury orbits the Sun quickly, completing a full orbit in only 88 days, it reaches this greatest elongation roughly every 116 days, giving us several chances each year to catch a glimpse. The angle between Mercury and the Sun during this event varies between about 18 and 28 degrees, depending on Mercury's elliptical orbit, which means some elongations offer better viewing than others. To see Mercury at greatest elongation east, you'll want to look toward the western horizon shortly after the Sun sets, ideally with clear skies and minimal light pollution. Using binoculars or a small telescope can help you spot this speedy planet as it twinkles low in the sky. This event isn't just a treat for casual observers. Ancient astronomers carefully tracked Mercury's elongations to understand its orbit and improve early models of the solar system. So next time Mercury reaches greatest elongation east, don't miss your chance to see one of the solar system's fastest and most fascinating planets lighting up the twilight sky. Why is Mercury's elongation important? Mercury's elongation is more than just a cool astronomical term. It's the key to unlocking our view of the solar system's swiftest planet. Because Mercury orbits so close to the Sun, it usually hides in the Sun's intense glare, making it one of the hardest planets to spot with the naked eye. But at greatest elongation east, Mercury reaches its farthest point from the Sun in the evening sky, giving us a rare and precious window to see it clearly. This elongation is crucial because it marks the moment when Mercury's position relative to Earth and the Sun allows sunlight to reflect off its surface at an angle that makes it visible just after sunset. Without this event, Mercury would remain lost in daylight, invisible to even the most dedicated stargazers. Observing Mercury at elongation helps astronomers track its orbit, study its phases, and understand its relationship with Earth and the Sun. It's also a reminder of the dynamic dance happening in our solar system, where planets race around the Sun at different speeds and distances. For casual observers, elongation is the perfect chance to spot Mercury's bright, quick-moving dot against the twilight sky, a fleeting glimpse of a planet that's always on the move. So, Mercury's elongation isn't just an astronomical curiosity, it's the planet's spotlight moment, a brief but brilliant chance to connect with one of our closest planetary neighbors. How often does Mercury reach greatest elongation east? Mercury's rapid orbit around the Sun means it doesn't take long for this planet to reach its greatest elongation east multiple times each year. In fact, Mercury completes a full orbit in just 88 Earth days, making it the fastest planet in our solar system. Because of this swift journey, Mercury reaches greatest elongation east approximately every 116 days, or about 3 times annually. This frequency gives skywatchers several opportunities each year to catch a glimpse of Mercury shining brightly in the evening sky. However, each elongation event is unique. Mercury's elliptical orbit causes the angle of elongation to vary, so some appearances are more favorable than others. The timing of these elongations also shifts slightly with each cycle, meaning the best viewing windows can fall in different months and seasons. This regular rhythm of elongations is a cosmic dance between Mercury's orbit and Earth's own movement around the Sun, creating a predictable pattern that astronomers have studied for centuries. For those eager to plan their skywatching sessions, knowing when Mercury will reach greatest elongation east is essential to maximize the chance of spotting this elusive planet. So mark your calendar roughly every 4 months, and prepare to look westward just after sunset. Mercury's dazzling show is ready to begin again. This frequent occurrence reminds us how dynamic and ever-changing our night sky truly is, with planets like Mercury constantly moving and revealing new wonders to those who watch closely. Typical angular distance during greatest elongation east. The angular distance between Mercury and the Sun during greatest elongation east is a fascinating aspect that determines how well we can see this speedy planet. Because Mercury's orbit is not a perfect circle but an ellipse, the maximum angle it reaches from the Sun varies each time it hits greatest elongation east. Typically, this angular separation ranges from about 18 to 28 degrees, which might not sound like much, but in the vastness of the sky, it makes all the difference. When Mercury is at the larger end of this range, around 28 degrees, it appears farther away from the Sun's glare, making it easier to spot against the twilight backdrop. Conversely, when the elongation is closer to 18 degrees, Mercury stays nearer to the Sun's bright horizon, making it more challenging to see with the naked eye. This variation is caused by Mercury's elliptical orbit combined with the relative positions of Earth and the Sun during the event. The changing angle affects not only visibility, but also the length of time Mercury remains observable after sunset. At wider elongations, Mercury can stay visible longer in the evening sky, giving skywatchers a better chance to enjoy its fleeting brilliance. Understanding this angular distance helps astronomers predict the best times to observe Mercury, and allows enthusiasts to plan their skywatching sessions accordingly. So the next time Mercury reaches greatest elongation east, remember that the exact angle it forms with the Sun plays a starring role in how spectacular the view will be. Visibility conditions for Mercury at greatest elongation east. Seeing Mercury at greatest elongation east requires the right conditions, and knowing when and where to look can make all the difference between spotting this elusive planet or missing it entirely. Because Mercury stays close to the Sun from our viewpoint, it appears low on the western horizon just after sunset during greatest elongation east. This means you need a clear, unobstructed view of the horizon, no tall buildings, trees, or mountains blocking your line of sight. Light pollution can also play a big role. The darker the sky, the easier it is to pick out Mercury's faint twinkle among the stars. The best time to observe Mercury is typically within 30 to 60 minutes after sunset, when the sky is dark enough but Mercury hasn't dipped below the horizon yet. Weather conditions matter too. Cloudless skies are essential because even thin clouds can obscure this small planet. Using binoculars or a telescope can help, especially if Mercury's elongation angle is on the smaller side, making it harder to distinguish with the naked eye. Keep in mind that Mercury's brightness varies, so sometimes it shines like a bright star, while other times it's more subtle. Patience is key. Mercury moves quickly across the sky, so catching it during this short window requires timing and a bit of luck. With the right conditions and a little preparation, you can enjoy the rare opportunity to see Mercury glowing in the twilight, a fleeting but rewarding sight for any astronomy enthusiast. Difference between greatest elongation east and west. Mercury's greatest elongation comes in two flavors, east and west, and understanding the difference between them is key to knowing when and where to look for this speedy planet. Greatest elongation east means Mercury is at its farthest point east of the Sun, making it visible in the evening sky just after sunset. This is your chance to catch Mercury glowing low on the western horizon as daylight fades. On the other hand, greatest elongation west happens when Mercury reaches its maximum angular distance west of the Sun, placing it in the morning sky before sunrise. During this event, Mercury rises early and can be seen shining near the eastern horizon just before the Sun peaks over the horizon. Both elongations offer rare windows to observe Mercury, but the timing and sky position differ significantly. The planet's rapid orbit and proximity to the Sun mean it never strays far from the solar glare, so these elongations are the only times Mercury becomes visible to us. Whether it's east or west elongation, the key is to know when to look. After sunset for east, before sunrise for west. This difference also affects how long Mercury remains visible. Sometimes it lingers longer in the evening sky, other times it's a fleeting morning visitor. Knowing these distinctions helps amateur astronomers plan their observations and never miss Mercury's brief but brilliant appearances in our sky. So whether you're an early bird or a night owl, Mercury's elongations offer exciting chances to connect with this elusive planet. Why does Mercury's elongation angle vary? Mercury's elongation angle isn't fixed. It changes every time the planet reaches greatest elongation east. And, well, this variation is all thanks to the shape of Mercury's orbit. Unlike Earth's nearly circular orbit, Mercury travels around the Sun in an elliptical path, meaning its distance from the Sun varies significantly over the course of its orbit. When Mercury is closer to the Sun, the maximum angle it can appear from the Sun in our sky is smaller, resulting in a narrower elongation. Conversely, when Mercury is farther from the Sun along its elliptical orbit, the elongation angle widens, allowing Mercury to appear farther away from the Sun's glare. This shifting angle is also influenced by the relative positions of Earth and Mercury as they both orbit the Sun, creating a dynamic interplay that changes the viewing geometry each time. Because of this, some elongations offer better viewing opportunities with Mercury appearing higher above the horizon and for longer periods, while others are less favorable, with Mercury hugging closer to the Sun and setting quickly after sunset. This variation makes each elongation event unique and honestly, adds an exciting challenge for skywatchers trying to catch Mercury's fleeting appearances. Understanding why Mercury's elongation angle varies helps astronomers predict the best times to observe the planet and deepens our appreciation for the complex celestial mechanics at play in our solar system. So the next time you spot Mercury at greatest elongation east, remember you're witnessing a moment shaped by the intricate dance of planetary orbits. How to observe Mercury during greatest elongation east. Observing Mercury during greatest elongation east is a rewarding challenge that requires timing, patience, and, well, a bit of preparation. Since Mercury appears low on the western horizon just after sunset, your first step is to find a location with a clear, unobstructed view of the horizon. Think open fields, beaches, or hilltops away from city lights. The best time to look is within 30 to 60 minutes after sunset, when the sky is dark enough to see Mercury, but the planet hasn't yet dipped below the horizon. Because Mercury is relatively small and close to the Sun, it can be tricky to spot with the naked eye, especially if the elongation angle is on the lower side. Using binoculars or a small telescope can greatly improve your chances, helping you distinguish Mercury's bright, steady light from nearby stars. It's also helpful to know Mercury's exact position in the sky for that evening, which you can find using astronomy apps or star charts. Keep in mind that Mercury moves quickly across the sky, so you'll want to be ready and focused during this short viewing window. Dress comfortably, bring a chair or blanket, and give your eyes time to adjust to the fading light. Watching Mercury at greatest elongation east isn't just about seeing a planet, it's about connecting with the rhythms of our solar system and witnessing a cosmic event that ancient astronomers marveled at for centuries. So grab your gear, head outside, and enjoy the thrill of spotting Mercury's fleeting glow in the twilight. Historical significance of observing Mercury's elongations. Observing Mercury's elongations has fascinated astronomers for thousands of years and played a crucial role in our understanding of the solar system. Ancient civilizations, from the Babylonians to the Greeks, carefully tracked Mercury's movements across the sky, noting its unusual behavior near the Sun. Because Mercury never strays far from the Sun's glare, its appearances during elongations were some of the few opportunities early astronomers had to study this mysterious planet. These observations helped shape early models of planetary motion, challenging the geocentric view that placed Earth at the center of the universe. In fact, Mercury's swift and irregular path was one of the puzzles that eventually led to the development of the heliocentric model, where planets orbit the Sun. Over centuries, astronomers refined their calculations of Mercury's orbit by studying its elongations, which also contributed to breakthroughs in understanding gravity and orbital mechanics. Even today, Mercury's elongations remain important for both amateur and professional astronomers, offering a chance to observe the planet's phases and gather data about its surface and atmosphere. This historical legacy adds a layer of wonder to every elongation event, connecting modern skywatchers with generations of stargazers who marveled at Mercury's fleeting appearances. So when you look up and spot Mercury shining near the horizon at greatest elongation east, you're not just seeing a planet, you're witnessing a moment steeped in centuries of astronomical discovery and human curiosity. Fun fact of Mercury. Mercury is a planet full of surprises that make it stand out in our solar system. For starters, it's the fastest planet, zipping around the Sun in just 88 Earth days, faster than any other world we know. Despite being so close to the Sun, Mercury has a fascinating quirk. Its day-night cycle is incredibly long, with one full solar day lasting 176 Earth days. This means the Sun rises, sets and rises again in some places, creating a strange double sunrise phenomenon. Another cool fact is that Mercury has a huge iron core that makes up about 75% of its diameter, far larger proportionally than any other planet. This massive core is responsible for Mercury's weak but detectable magnetic field, which is surprising given how small the planet is. Even more intriguing is that despite Mercury's scorching proximity to the Sun, NASA's MESSENGER mission discovered pockets of water ice hidden in permanently shadowed craters near its poles, places so cold that ice can survive despite the extreme heat elsewhere. Unlike Earth, Mercury has almost no atmosphere, so its sky is always black, even during the day. Its surface is heavily cratered and marked by giant cliffs and valleys, telling a story of violent impacts and geological activity. Named after the swift Roman messenger god, Mercury truly lives up to its name with its speed and mysterious features, making it one of the most fascinating planets to explore and observe in our cosmic neighborhood. Thanks for watching this deep dive into Mercury at Greatest Elongation East here on InnoVision Tech. If you enjoyed exploring the mysteries of our solar system's fastest planet, don't forget to hit that subscribe button and ring the bell icon so you never miss our latest tech and space insights. We love hearing from you, so drop your thoughts or questions in the comments below. What fascinates you most about Mercury? Join our community, and let's keep exploring the future of technology and the cosmos together. See you in the next video.